Greetings, class. This first segment is designed to be an introduction, just some opening remarks about the next procedure that we're going to work with, and that procedure is known as ANOVA, or specifically analysis of variance. That's what ANOVA stands for. So when I say ANOVA, that's the word I'm referring to on the sheet here, and it is analysis of variance. So perhaps unsurprisingly, that is what is being analyzed via an ANOVA. You're analyzing variance. Analysis of variance is also referred to as an F-test. An F-test. Now, here is what the purpose of ANOVA is. The purpose of analysis of variance, or the purpose of an F-test, those two things are interchangeable. F-tests are used when we need to compare more than two groups simultaneously. So up to this point, in recent weeks, you conducted a t-test for one sample, which meant you took one group and compared that group to an assumed population. Then, after that procedure, then you conducted t-tests for two samples, specifically t-tests for two independent samples. And in that test, you compared not one group to an assumed parameter, but rather two groups together, group 1 and group 2 together. Analysis of variance involves the comparison of the simultaneous comparison of more than two groups. More than two groups. Technically speaking, there is no limit to the number of groups or the number of samples that can be involved in a one-way ANOVA or in an F-test. But I should note that the more groups involved, the somewhat less meaningful the conclusions that we can draw, and hopefully that statement, if that statement seems a little bit abstract, it will seem less abstract as we move on. I think next one of the best ways to to continue introducing one-way analysis of variance, one-way ANOVA or F-tests, would be to examine the hypotheses and talk about hypotheses that can be used, hypotheses that would require an F-test. In Blackboard, I've placed a packet, and in that packet you'll find this document here. This document is called, the file name at least is called Examples of Hypotheses Requiring One-Way ANOVA. And in fact, that's what's written at the top of this page. This is what that document looks like. The file is called Examples of Hypotheses Requiring One-Way ANOVA. And you can see those words also right here at the top of the sheet. Examples of hypotheses requiring one-way ANOVA or F-tests to test. So, for example, let's take a look at example of hypotheses for ANOVA number 1. And it probably goes without saying, but feel free to pause this video if you don't have that sheet in front of you, because I am going to read from that sheet briefly, at least a little bit. Example of hypotheses for ANOVA number 1. Again, examples of hypotheses for ANOVA number 1. H sub 1, that's the research hypothesis, so that's the same thing as before. Here's the research hypothesis. Chicago, New York, Los Angeles, Miami, and Seattle will have significantly different rates of violent crime. Okay, H sub 1, the research hypothesis. H sub 1, Chicago, New York, Los Angeles, Miami, and Seattle will have significantly different rates of violent crime. The null hypothesis, H sub 0, is Chicago, New York, Los Angeles, Miami, and Seattle will have the same or equal rates of violent crime. Now, like before, it is the null hypothesis that we are actually testing. It is the null hypothesis that we will put directly to the test, and as such, it is the null hypothesis that we will make a definitive statement whether we reject or retain the null hypothesis. Again, like before, the null hypothesis is the hypothesis of equality. So under those hypotheses, Chicago, New York, Los Angeles, Miami, and Seattle will have significantly different rates of violent crime. Null hypothesis is Chicago, New York, Los Angeles, Miami, and Seattle will have the same or equal rates of violent crime. Underneath those hypotheses, it says, note, there are 5 groups or things, in this case 5 different cities, are being compared regarding their rates of violent crime. So the 5 groups or things that are being compared are cities. Okay, so cities, what city we're referring to, provides the basis for the groups that we're comparing. And then the interval level variable that we are going to compare across those cities is, as you can see from the hypothesis, rates of violent crime. So 5 groups or things, in this case 5 different cities, are being compared regarding their rates of violent crime. Let's look at another example before we move on to the next segment. Example of hypotheses for ANOVA number 2. H sub 1. Freshmen, sophomores, juniors, and seniors will drink significantly different amounts of beer. So the research or alternative hypothesis is saying that those 4 groups, freshman, sophomore, junior, senior, are going to be different regarding the amount of beer they consume. H sub 0, the null hypothesis, is freshmen, sophomores, juniors, and seniors will drink the same or equal amounts of beer. And underneath that those hypotheses, it says, note, 4 groups, in this case groups are defined as the year in school they belong to, are being compared regarding the amount of beer they consume. So we have 4 groups that are defined by year in school, and they are being compared regarding the amount or the quantitative measure of beer that they drink. Okay, I think I'm going to cut this off and finish the rest in another segment.